Okay, so for question 9, we're continuing on with the same problem about the jumping antelope, and again jumping flat ground at 8.3 meters per second at an angle of 55 degrees from horizontal. In question 8 we determined that the initial y velocity was 6.8 meters per second. So in question 9 we're thinking about how far or what's the maximum height the antelope reaches. So the key part for two-dimensional motion is knowing that the y velocity at the maximum height is 0. So make that statement is that v, maybe just stating that vy is equal to 0 meters per second at the maximum height. And using that information, we know the initial y velocity, and we know that's going to be in free fall. So we could take the time to find the delta t time of flight, but it's not important for this particular question, because we can write the final y velocity squared is equal to initial y velocity squared minus 2g delta y. So vfy is 0, so we can make this all equal to 0 for when noting that for determining the delta y from the bottom to the maximum, that this delta y will refer to the maximum delta y, where the vfy goes to 0. Then I can state that viy squared is equal to 2g delta y. I'm trying to solve for delta y, so delta y will be equal to viy squared divided by 2 times g. So that will be equal to the viy from question 8, so 6.8 meters per second, all to be squared, divided by 2 times 9.81 meters per second squared. And if you carry out this calculation in your calculator, find that the maximum height is 2.4 meters, or this is the delta y that the antelope climbs until its y velocity is 0. So starting out with a 6.8 meters per second y velocity, it'll climb 2.4 meters before its y velocity becomes 0, and that would represent its maximum height before it starts returning back to the Earth. So this would be choice C is the correct answer.